Key issues in BOPP manufacturing, the reasons and remedies. Part 4. What are the benefits of a gap rule relative to a winding nib? Here is a picture, you can have a look. A gap roller has the same anti-wrinkle and improved tracking benefits of a pack roll. However, since it does not create pressure or force on the outer layer, there is no air squeeze or nib included. Tension benefits. Individual top riding rolls are used to obtain straight, smooth-sided revolved rolls at high and low speed. When winding of gauge, high slip, light tension problem materials. Of all the progress which has been made with regard to the slitting and rewinding of these materials, the development of the individual top riding roll for each individual rewound roll is probably the most outstanding engineering advance. Efficient subsequent operations to a large extent depend on the smooth edges, even density rolls of packing materials which can be produced on the slitting rewinding equipment. Four major factors must be compensated for in order to produce the desired slit and rewound roll. These factors are gauge variation, gauge band, slack zone, and entrained or entrapped surface air, which acts as a lubricant when an excessive amount is trapped and wound within the wound rolls. All materials carry a surface air layer with them as they move through a machine. When films are slit and rewound, this air layer is carried towards and partially into the rewound roll. At low machine speeds, most of this air layer can escape as the web enters the rewind roll without causing a problem in winding. However, at high speeds, an excessive amount of air enters the roll and this results in conditions. Number one, air becomes a lubricant and acts as a frictionless separator between the layers of material, allowing shifting of second, third, and low layers within the convolutions of the roll. Number two, air is trapped between the layers of material and is wound into roll. Once inside the remote roll, it forms tiles or balloons or bubbles which can have various detrimental effects depending upon the characteristics required of the finished roll. The top riding roll may be 3-inch ID paper cores mounted on two flange ball bearings in turn-mounted or aluminum tubular central shafts. These are held in position by easily removed arms and are quickly changed from one width to another by simply changing the paper core or the whole assembly. For maximum utilization of these individual top riding rolls, it is necessary to have the incoming web enter into contact with the rewinding roll at the point of contact with the individual top riding roll or better yet to wrap around the top riding roll. If the incoming web contacts the rewind roll some distance ahead of the individual top riding roll, the tracking and guiding effect of the top roll is lost. Once this has occurred, it is extremely difficult, if not impossible, to force the air out. Leon rails. Leon rolls are manufactured and used to help reduce air entrapment when winding. Leon rolls are manufactured and used to help reduce air entrapment when winding. They are utilized within the paper, film, foil, and plastic industries. High speeds on web processing machines with tighter parent roll properties. They are utilized within the paper, film, foil, and plastic industries. Winding better roll. It is not obvious how winding adds value to your product. It does, but it is obvious when it is done poorly. Winding. It seems easy enough, but done poorly, winding can turn 100% good product into waste very quickly. One key to quality wand rolls is the winding nib. The winding nib is a roller driven or idling that remains in contact with the winding roll without its buildup. The winding nib has many aliases including Leon roller, pack roller, surface roller, and contact roller. Some of the same roll quality benefits also are found using a close cousin of winding nib, that is the gap roll. Question: are winding nib rolls used in both surface and central winding? Answer: yes. Winding nib rolls are used in both. You cannot have a surface winding without a winding nib roll. Pop reel winders have one large central drum that contacts the winding roll. A two-drum winder has two winding nibs that cradle the winding roll and often a third winding nib on top of the row. Adding a winding nib to a central winder improves the roll quality. Which is most common, surface or central winding? If you survey winding equipment shown at the CMM show, central winding dominates the converting industry. This domination is not because it is the best winding method, but because it is simpler to build and easier to automate rule transfers. In the paper industry, you will see more surface winding for two reasons. First, paper roll properties allow winding to extremely large diameter build-up ratios, where the final roll's diameter may be 20x the core diameter, that is 20 times. If tensioning torque is generated from the roll center, the definition of central winding, the torque required, that is tension multiplied by radius, will have a torque range impossible for most motors. Surface winding takes roll diameter out of the torque range requirement. Second, many paper winders use a simple rip and tuck rule transfer. If there is a core start wrinkle, the soft paper layers quickly mask them. You could never do a rip and tuck with films or foils without a lot of waste from wrinkles and impressions, so central winding and automated or stop transfers are preferred. Why does the winding nib improve the roll quality? Here is a picture in which it is explained how that gives a benefit: less wound air, better alignment, the entrapped air is reduced, the uneven side escapes can drive the web laterally. The web roller friction easily opposes the reactive motion. Winding nips do a better job of managing the web's large span and initial contact onto the winding rod. Mismanagement of the web's final span before winding is like the poor grocery beggar. What are the benefits of a winding nip? The winding nip has four main functions. First, it reduces the span length into the winding rule, reducing tracking errors and wrinkles. Second, it acts as a squeezing, reducing the air entrapment into the winding rule. Third, it tends to form more cylindrical rolls. Finally, it tightens the winding. How does winding entry span length promote tracking and wrinkling defects? The three sources of web tracking error are misalignment, diameter variations, and web bagginess. Winding rules can have one or all of these errors, especially diameter variation. Because the web's flexibility goes up with span length cube, the magnitude of tracking error from these sources will increase with longer entry span. What is an example of span length increasing tracking error? Many turret winders have wrinkles and tracking error during the index cycle. Entry-level turret winders have a winding nip in the primary winding position, but the nip does not contact the rule once the index cycle begins. As the rule indexes away from the winding nip, the winding entry span length increases. In many cases, the non-cylindrical winding rule and the long span formed during indexing will cause wrinkling or tracking errors. For faster processes and thicker products, this will cause a high percentage of wasted. How are indexing wrinkles eliminated? In some designs, rollers on the turret that limit the span length during indexing are enough. More advanced winders keep winding nip contact throughout the index circle. Where do rule diameter variation comes from? Here is a picture you'll be able to see, you'll be able to study. The cross web caliper variation and the slit edge quality creates rule diameter variation. Winding conditions and material properties such as radial modulus will determine whether winding magnifies or masks web thickness variation. Should a winding nip be held parallel or allowed to float to the roll profile? Here is a picture how the two ideals are mismatched and how it can create a wrinkle and how the wrinkle video will have effect on the winding quality. Floating winding nips can promote tracking errors. Most winding nips are designed to maintain their tram and level. How does a winding nip increase rule tightness? More winding nip force creates a tighter rule similar to winding with higher tension. To understand the nip induced tension effect, think about rolling a cart or a rug. The nip force of the cart's weight on the wheels has a rolling pin action elongating the rug. As the cart rolls in one direction, the rolling wheels elongate and pin down the stretch rug. The elongated material is pushed ahead of the cart, forming a bulge in the carpet. If you held the rug at both ends while you rolled the cart, you would find the rug behind the cart got tighter and the rug section ahead of the cart got looser. The same elongating and pinning happens with a winding nib only in the reverse direction. The web moving under the nib is elongated and pinned into the winding rule. Therefore, the web tension increases as the web passes under the winding nib. Here is a picture how the air travels with the rule. What determines how much added tension is created by winding nib. In both the rug and winding nib case, the top layer or rug must slide relatively to the surface below it to elongate. If the layer or rug cannot slide, it cannot elongate. The winding nib cannot induce more tension than the frictional force at the sliding point. Therefore, front to back web coefficient of friction or rug to floor friction determines how much elongation or tensioning occurs for a given winding nib rule. When is a gap rule used instead of a winding nib? If you want the tracking and wrinkling benefits but have a pressure or tension sensitive product, then gap winding is a better option. If your product has high friction or adhesive coating, the outer layer will not slip relative to the winding roll, so you cannot benefit from the nib induced tension. If you find entrapped air improves your winding quality, gap winding is better for your product. The function of the last roller before entering the winding rule is critical to optimize roll quality. Nip and gap winding both will reduce lateral errors and wrinkling associated with long entry spans and roll variation. Winding nips will reduce entrapped air and associated loose wind or vacuum process pump downtimes. Winding nips are an alternate variable to increase roll tightness and many promote roll cylindricity. Just like a good grocery assistant will put your milk and eggs in a bag safely, nip and gap winding will secure your web safely into the winding roll. Here is a picture of a typical slitting machine. You can call it as a cross section. And here you see it's a typical example of surface winding, which will help you a lot in avoiding air entrapment. Here are some pictures of machines that generally operate in India. See the amount of wrinkles in both the photographs. This is a good quality slit material. You see the winding is square. It's very even. Here is another picture explaining the same. Just to sum up, adhesive wide and strict. Description: PSA tape exhibits non-continuous coverage of adhesive. Possible causes: adhesive coating equipment coats a strict coating, insufficient adhesive supply to adhesive coating equipment, pump malfunction, adhesive confusion during slitting of free film or the transfer tape product. Possible causes: ensure that adhesive coating equipment coats stick-free coating. Ensure that sufficient supply of wet adhesive is pumped to adhesive coating equipment. Ensure that no ancillary parts come in contact with wet adhesive. Address adhesive confusion issues as outlined below. Adhesive confusion means adhesive transfer. Adhesive doesn't understand on which side it should remain. That is why it is called as adhesive confusion. Adhesive confusion or transfer. In rolled form, PSA does not unwind cleanly and adhesive splits between two sides of film and or the release liner. The slit tip adhesive may split between coated side and backside. The possible causes: selection of unsuitable adhesive or the release coating, rough cut and or tacky edges created during slitting or rewinding process, non-continuous release coating on backside, corner treatment on both sides of the film, disruption of cured release coating by static electricity. Possible solution: select product with different adhesive, modify roll slitting rewinding process to minimize edge defects, clean the slitting blades prior to starting the machine, use scratch-free release liners or see that the release coating is even, check and install appropriate static electricity elimination devices. In converted part, implement and document consistent lamination processes. Old adhesive. Appearance or adhesive properties of PSA product exhibit significant change since initial purchase or use. The colorless adhesive product top sample may turn dark in color or darken under severe conditions. Possible causes: PSA exceeded a manufacturer recommended shelf life, PSA exposed to extreme temperature or UV light or other environmental conditions. In a converted part, PSA becomes incompatible with the substrate over time. PSA manufactured without, without adequate preservative. The possible solutions: plan to use PSA product prior to expiration or expiry date. Store PSA products per manufacturer's recommendations. Avoid direct UV exposure or sunlight. Prepare prototype parts and predict competitively using accelerated aging studies. Contact PSA manufacturer to confirm that PSA product was manufactured properly. Pinholes in tape. Description: converted or unconverted tape exhibits pinholes through substrate. Possible causes: pinholes may occur frequently as part of a foam formation in manufacturing process. Pinholes and other physical defects may be created as foam adhesive coated film passes or contaminated equipment drive and idler rolls. Excessive corona treatment used to improve anchorage of PSA to the lower energy surface of polyethylene or polypropylene or other plastic substrate, which may cause pinholes. The excessive corona treatment, in this case, there are chances that the backside also get some sort of treatment and it disturbs the coating. Possible solutions: inspect suspect raw material closely and review situation with raw material vendor or supplier. Inspect suspect coated material equipment drive or idler rolls for source of contamination and surface defect. Pinholes created by corner treatment may be the result of the equipment setup, process conditions, or maintenance. Confirm proper corner treatment setup and conditions per process specification. Inspect corner treatment equipment for proper operation. Also inspect the corner treated surface by using corner checking solutions which are readily available. Low release, too low release. PSA tape unwinds too easily or too soon. In such cases, high waste is incurred due to pre-dispensed part and or dirt contamination. The possible causes: selection of unsuitable PSA, selection of unsuitable release coat, or too low adhesive coat weight. Possible solutions: select product with different adhesive or release coating combination to provide proper release performance. Consider using a tighter release formulation or don't release coat at all. Too low release may be affected by the direction of wind, core size, and other finishing packing factors. Consider such factors along with adhesive and film. Poor release liner due to static. PSA roll does not unwind cleanly and the adhesive splits between two sides of the film or release liner. Adhesive splitting or transfer defect may be confirmed by marking suspect area with large permanent marking pen. Possible causes: selection of material that are susceptible to static such as polymer films, low moisture and humidity in the processing area, film slides or equipment drive idler rules creating static electricity. The possible solutions: be aware of static electricity potential and maintain adequate static control equipment. Be aware of static electricity potential with high friction liners. Add humidity to facility and or specific equipment environment. Minimize material slippage through equipment. Moisture related tunnel and wrinkles. PSA tape or converted part exhibits small puckers or wrinkles. Large moisture-related air pockets may also form between adhesive and backside of the PSA tape. The possible cause: selection of unsuitable adhesive or film combination. Moisture stability is critical. Significant relative humidity fluctuation between PSA manufacture, customer storage and use. Possible solutions: optimize PSA tape manufacturing processes to minimize drying efficiency, maximize drying efficiency, control environmental relative humidity in storage and manufacturing facilities, protect PSA products from extreme moisture and humidity variation by storing PSA tape and converted parts in polypacking. Other tunnel wrinkles. PSA tapes may exhibit wrinkles, tunnels, or air pockets not directly related to moisture stability issue. Two common defects are hard wrinkle and roll winding tunnel. Possible causes: hard lamination wrinkles may be the result of combined material and process issues, baggy raw materials, inconsistent adhesive thickness, tension and lamination operations, adhesive sticks, voids, etc. Roll winding tunnels may also be the result of consistent adhesive coating and roll finishing process. Possible solutions: select PSA tape product manufactured with top quality, cost effective raw materials. Ensure that all adhesive coating, lamination, roll finishing processes are capable of producing defect-free product. Carefully evaluate multiple material components, processing conditions, and roll storage combinations to minimize the occurrence of such roll defects. Poor roll formation, rolls too tight. The tension curled materials exhibit down web curls and tend to wind itself up into a small coreless tape roll. Moisture curled material exhibits cross web curl and tends to roll up into the tube of material. Similarly, high sensitive raw materials may shrink and exhibit cross web curl as described above for moisture related issues. Possible causes: selection of soft, easily stretched material such as thin, lightweight films, inconsistent tension control of film during adhesive coating process. Possible solutions: optimize tension control during adhesive coating, curling, and rewind process to manufacture curl-free. Adhesive bubbles and blisters. PSA tape exhibits excessive bubbles, blisters in cured adhesive coating. The possible causes: selection of unsuitable adhesive. Self-on tape may exhibit mottled appearance due to entrapped air between the tape layers. Adhesive coating process that results in bubbled, wet, or cure coating. Adhesive curing process that results in adhesive scaling or blistering. The possible solutions: heavy adhesive coating weights coating may result into blistered adhesive coating. Mottled appearance may be eliminated by using a non-diluted adhesive. Optimize coating processes to apply bubble-free wet adhesive coating. Optimize curing process to ensure bubble-free cure, curing of wet adhesive. Another solution could be use a Leon roll or nipping roll prior to winding, which will push off the entrapped air. Material curl, tension, selection, shrinkage, moisture related. Tension curled material exhibits down web curl and tends to wind itself up into a small core-less tape roll. Moisture curled material exhibits cross web curl and tends to roll up into a tube of material. Similarly, heat-sensitive films may shrink and exhibit cross web curl as described above. Possible causes: selection of soft, easy stretched film, inconsistent tension control on film during adhesive coating and rewinding process. Possible solutions: optimize tension control during adhesive coating, curling, and rewinding processes to facilitate manufacture of curl-free products. Jai Hind, Vande Mataram. Let us serve our nation. You can reach me on my WhatsApp numbers. You can join me on LinkedIn.com. I got nearly 12,500 contacts worldwide. You can also join me on Facebook. There I do have contacts more than about or close to about 5,000. You can speak to me on Skype. You can visit my YouTube channel and you can subscribe so that all the new videos uploaded will be available on will be directed to your inbox automatically. This is my contact details. नमस्कार. आप स्वस्थ रहे, खुश रहे, आपका दिन शुभ हो. Thank you very much. See you very soon with another video.